Hey guys, what's up? It's your boy Trix. Today we're going to be doing some more Rust. This is a very impromptu stream because I was streaming earlier, might as well continue streaming. So, let's get started, shall we? So if I CD in the docs, programming CD into Rust Rogue. Whoops. Whoops. There we are. In the last few chapters, we focused on getting a playable, if not massively fun game going. You can run around, slay monsters, and that's great. Most games. Okay. If you're going to resume a game, you need somewhere from which to do so. A main menu also gives you the option to abandon your last save, possibly view credits, and generally tell the world that your game is here and written by you. It's an important thing to have, so we'll put one together. Being in the main menu is a state. So we'll add it to the never expanding run state enum. We want to include menu state inside it. So the definition winds up looking at this. So I'm pretty sure that's in main. And then run state is, where is it? That's new run state. Run state enum, match enum. Ooh. Hang on. Run state. Hang on. Enum run state. There we are. Pre-run meet, and there we are. Show targeting, and then we've got main menu. You know what? This will probably look a lot nicer if I just copy paste it from here, wouldn't it? There we go. In GUI.rs, we add a couple of enum types to handle the main menu selections. So let me just grab this. Let me go all the way to the bottom. Let me add this. Cool. Your GUI is probably now telling you that main.rs has errors. It's right, we need to handle the new run state option. We'll need to change things a bit to ensure that we aren't also rendering the GUI and map in the menu, so we rearrange tick. So let me just grab this. You know what, I'm going to read through it and then I'm going to copy paste it from the original docs and then I'll update. So it's pretty much gold standard for serialization in Rust. It makes a lot of things easier. So first step is to include it in the project's code, and we'll add the dependency section to include. maybe we're calling cargo run now. It'll take a while. Don't need independent season and building. Okay. Adding save game state. We'll extend run state will support game saving, and tick will add dummy code, and play.rs will add another keyboard handler getting started with saving game. Now that scaffolding is in place, it's time to actually save something. Let's start simple to get a feel for SSS. In the tick function, we extend the save system to just dump a JSON representation of the map to the console. We'll also need to add an xzone create SSS to the top of main RS. This won't compile because we need to tell map to serialize itself. Fortunately, SSS provides some helpers to make this easy. At the top of map.rs, we add use SSS deserialize. We then decorate the map to derive serialization and deserialization. Note that we decorate tile content with directives to not deserialize it. This prevents us from needing to store entities, and since this data is rebuilt every frame, it doesn't matter the game still won't compile. We need to add similar decorators to tile type and rect. If you cargo run save the project now, when you hit escape, it will dump a huge blob of JSON data to the console. That's game map. Saving entity state now. We've seen how useful SSS is. We should start to use it for the game itself. This is harder than one might expect because of how specs handles entity structures. The ID number is purely synthetic with no guarantee that you'll get the same one next time. Also, you may not want to save everything, so specs introduce a concept of markers to help with this. It winds up being a bit more of a mouthful than it's really needed to be, but gives a pretty powerful serialization system. Introducing markers first of all. In main.rs, we tell Rust that we would like to make use of the marker functionality. Components will add a marker type. Back in main, we'll add serialize me to the list of things we register. We'll also add an entry of the ECS resources, which gets used to determine the next entity identity. Finally, in spawner.rs, we tell each entity builder to include the marker. Here's the complete entry for the player. New line marked, simple marker, serialize me, needs to be repeated for all of our spawners in the file. It's worth looking at the source of this chapter to avoid making a huge chapter full of source code, so I've omitted the repeated details. Convert saveler derived macro. The entity class itself, provided by specs, isn't directly serializable. It's actually a reference to an identity in a special structure called a slot map. So in order to save and load entity classes, it becomes necessary to convert these synthetic identities to unique ID numbers. Fortunately, specs provides a derived macro called convert save load for this purpose. It works for most components but not for all. It's pretty easy to serialize a type that doesn't have an entity in it but does have data. Mark it with hashtag derived clone. So component convert save load. So we go through all the simple component types in component.rs. For example, here's the position. So what is this saying? Is that structure as a component, you can replace this with writing code specifying spec storage if you prefer, but the macro is much easier. Convert sailor is actually adding serialize and deserialize, but with extra conversion for any entity classes it encounters. Clone is saying this structure can be copied in memory from one point to another. This is necessary for inner workings of SSS and also allows you to attach .clone to the end of any reference to a component and get another perfect copy of it. In most cases, clone is really fast, and occasionally the compiler can make it do nothing at all. When you have a component with no data, the convert save load macro doesn't work. Fortunately, these don't require any additional conversion, so you can fall back to the default SSS syntax. Here's a non-data tag class actually saving something. The code for loading and saving gets large, so we moved it into save load system.rs, then include a mod save load system in main.rs and replace the save game state with it. So onto implementing save game. SSS and specs work decently together, but the bridge is still pretty roughly defined. I keep running into problems like it failing to compile if I had more than 16 component types. To get around this, I built a macro. I recommend just copying the macro until you feel ready to learn Rust's impressive macro system. Short version of what it does is that it takes your ECS as a first parameter and a tuple with your entity score and markers stores in it. You'll see this in a moment. Every parameter after that is a type, listing a type stored in your ECS. There are repeating rules, so it issues one serialized component serialized call per type. It's not as efficient as doing them all at once, but it works and doesn't fall over when you exceed 16 types. Say game function then looks like this. What's going on here? We start by creating a new component type serialization helper that stores a copy of the map, we see we are using the map stuff from above. It then creates a new entity and gives it a new component with a copy of the map. The clone command makes a deep copy. This is needed so we don't need to serialize the map separately. We enter a block to avoid borrow checker issues. We set the data to be a tuple containing the entity store and read storage for simple maker. These will be used by the save macro. We open a file called savegame.json in the current directory. We obtain a JSON serializer from insert. We call the serializer individually macro with all of our types. We delete the temporary helper entity we created. If you cargo run and start a game, then save it, you'll find a save game JSON file has appeared with your game in an EA. Restoring game state. Now we have the game data. It's time to load it. Is there a save game? Firstly, we need to know if there's a save game to load. In save load system.rs, we add the following. I need to make a file. Then in agree.rs, we extend the main menu function to check if the existence of a file and not offer to load it if it isn't there. Finally, we'll modify the code in main.rs to call the game loading. Actually, then in the game in save load system.rs, we're going to need another macro. This is pretty much the same as serialize individually macro, but reverses this process and includes some slight changes. This is called from new function load game. That's quite a mouthful, so let's step through it. Inside a block, to keep the borrow checker happy, we iterate all entities. In the game, we add them to a vector and then iterate the vector, deleting the entities. This is a two-step process to avoid invalidating the iterator in the first pass. We open the savegame.json file and attach a JSON deserializer. Then we build the tuple for the macro, which requires mutable access to the entity store, write access to the marker store, and an allocator from specs. Now we pass that to the macro we just made, which calls the deserializer for each type in turn. Since we saved in the same order, it will pick up everything. Now we go into another block to avoid borrow conflicts with the previous code and the entity deletion. We first iterate all entities with serialization helper type. If we find it, we get the access to the resource storing the map and replace it. Since we aren't serializing tile content, we replace it with an empty set of vectors. Then we find the player by iterating entities with a player type and a position type. We store the world resources for the player entity and her position. Finally, we delete the helper entity so we don't have a duplicate if we save the game again. If you cargo run now, you can load your save game. It wouldn't really be roguelike if we let you keep your save game after you reload, so we'll add one more function, save load system. We'll add a call to main.rs to delete the save after we load the game. It'll compile and run the WebAssembly, but as soon as it tries to go, it crashes. Fortunately, if you like your computer not being attacked by every website you go to, WebAssembly is sandbox and doesn't have the ability to save file locally. Supporting saving via local storage is planned for a future version of RLTK. In the meantime, we'll add some wrappers to avoid the crash and simply not actually save the game on WebAssembly32. Rust offers conditional compilation. If you are familiar with C, it's a lot like #divine madness you find in big cross-platform libraries. And save load system will modify the save game to only compile on non-WebAssembly platforms. The hashtag tag is scary looking, but it makes sense if you unwrap it. CFG means only compile if the current configuration matches the contents of the parentheses, not inverts the result of the check. So when we check the target arch from WASM32, are we compiling for WASM32? The result is inverted. The end result is that the function only compiles if you aren't building for WASM32. That's all well and good, but there are calls to that function. So compilation of WASM32, WASM will fail. We'll add a stub function to take its place. The CFG target arch WASM32 prefix means only compile this for WebAssembly. We've kept the function signature the same but added a underscore before underscore ECS, telling the compiler that we intend not to use that variable. Then we keep the function empty. The result, you can compile for WASM32 and save game function simply doesn't do anything at all. The rest of the structure remains, so the game correctly returns to the main menu, but with no resume function. Why does the check that the file exists work? Rust is smart enough to say no file system, so the file can't exist. Thanks, Rust. The great news is that now we have a framework for loading in the game whenever we want to. Adding components and gain some stats. We have to register them in main, tag them as serialized, deserialized, and remember to add them to our component types, and that could be easier, but it's a very solid foundation. Okay, so now it's going to be a lot of copy pasta. Have no idea why it's 16 and 17 in here. 17, 0410, 93 for CERD, that's fine, it's a higher version, so it doesn't matter. CERD JSON, I'm going to change to 44. Cool. And now is where the full copy pasta comes in. Even my browser's like, oh, I don't want to do it because it knows there's going to be a ton of copying. Come on. Components. Cool. Damage system. Game log. I doubt game log has changed actually. Yep, still the same. GUI. Let me just go to the top. Inventory system. Cool. That's main.rs done. Let's do map. Map indexing system. Melee combat. Oh shit. Monster AI. player. Ooh, what? Why is player calling player? Hang on. Save, load, system.rs. Visibility. Alright, let's see if I can cargo run. Cargo build. This is gonna take a while. I realize now that I'm sharing my screen, this is the first time you guys are gonna actually see the game running. Hang on a sec. So I need to fix GUI and main. And that's deprecated. Deprecate is fine. So GUI and main need fixing. And then main. Actually, I think that'll fix it now. There we are. So if I cargo run, you guys should be able to see. This is the game. Took bloody forever for me to be like, yeah, this is the game now. Oh, it doesn't work with the Vim bindings. It works for the Vim bindings inside the game. That's just pain. So this is my cursor, obviously, and it turns up like this. So if I go and I think enter? Is it enter? No. I? No. E? A? No. What was it? No. U? No. U? No. M? No. No. B? No. What was the command? I need to go into play with the RS because I've forgotten what the command is to pick up items. I thought it was enter. Try move. J-U-N-P. Picking up, there we go. It's G. There we are. I is for, yeah, and then A to use it. There we are. So if I go around, you can just see. And then if I choose I, A, health is up again. And I'm dead, right? So if I Control Shift C, there we are. That quits the game, obviously. And then I believe if I were to, I'd only be able to show it if I like ls in another terminal while I'm open. Actually, I can do that. Cargo run, that's fine. And then I just want to make a new terminal instance. Let me just make a new instance. There we are. This is big. There we are. Let me just chuck this over here. I want to begin the new game, right? So if I cd into docs, land program, cd into Rust Rogue, cd into Rust Rogue, and then cd into SLC, I think? No. cd into resources. Hang on, because I know it saves the game somewhere. Oh, I need to click quit, right? Yeah. And then if I'm in here, it has save game.json, right? So if I load the game again, cargo run, it'll begin a new game or load game. If I click load game, it takes me back to the same map, so it doesn't generate a new map. But I believe if I quit, no, I need to die, don't I? Because it still exists, yeah. Yeah, if I begin a new game, it will overwrite my old game, right? I just need to die, so hang on. Let me just fight this ogre. There should be another one somewhere. Let me just go all the way this. There's one here. There we go. I should die now. No. But damn, I'm tanking for some reason. There we are. I'm dead, right? So if I should just see. And then ls. Save game should not be there. Why is save game there? What happens if I load from a game where I'm dead? Yeah, cool. Quit. Anyway. Let me just fill this out. Alright, I'm back. Sorry about that. Including third. Okay, cool. And then next time we are going to be working on when it loads, delving deeper. Cool. Come on, there we are. Cool. Thanks for watching. If you liked the video, well, same usual stuff. Like, subscribe, enjoy the rest of your day, and peace.